Hi folks, welcome to the Distributed SQL Summit 2022. I have with me Marc, and it's going to be, he is a DBA from the Oracle days, like really an expert in Oracle, and into the world of Distributed SQL more recently. And so this is going to be a very interesting talk where we cover how from a DBA's point of view and from an infrastructure point of view and from the point of view of automation, how the distributed SQL world looks. But anyways, before we get started, I'm going to turn it over to you, Marc, to maybe quickly introduce yourself and let's get it started.
Sure. I'm Marc. I'm actually by trade an Oracle DBA for the last 20 years, doing either just straight homegrown Oracle database administration, or in the last 10 years I did Oracle ERP systems and Oracle apps. And then as part of that, just a lot of in-house things, order entry, transactional things to run a warehouse, and those kind of things. And those databases can be small to large.
Fantastic. And maybe quickly talk about which company you're a part of, what they do. Let's get that.
Okay. Yeah, and I'm part of the Fiserv, and specifically that where I was doing it was within what's called Fiserv Hardware Services, and they did a lot of shipment of point-of-sale equipment and their paper out supplies to merchants so that they would have the ability to print you a receipt when you go in to do your transaction on the hardware we shipped out. Mm-hmm. Now I've moved into more just operations and implementation of databases as a service, different providers, and how we can utilize those within Fiserv itself.
Fantastic. So let's maybe start with the database as a service part, right? So could you talk about what that means to you? Like, what is database as a service, and why is it necessary?
Yeah, from a loose perspective, it's just how can we provide database from a point-and-click operations. DBAs tend to be a lot more, at least within Fiserv, a manage the container perspective. And we spend a lot of time wrapped up in deploying or building a new database for a business unit. Somebody who has an idea of what they want to do, and they want some database to actually run that out of. And database as a service is something where a business unit or a dev team can go, and whether it's click a button and I have a database 15 minutes later, or something along those lines, it's moving away from a long deployment line where it's a month, 2 months from the point in time of request till you actually have a database to actually work on, and you still don't even have the actual application schema built in it. Database as a service is 10, 15 minutes, I have a database, and now it's handed over to me as an app dev team, and I can deploy and I can use it.
Got it. So I've heard that many times, right? And one thing that might be interesting to just quickly touch on before we go to the next topic is, why did it take 2 months? What was the, like in the old way, non-database as a service way? Why would it take that long? What were the long
You get into a lot of things. It's just, how do we get the stuff? First you got to figure out the hardware. Where do we put it? Somebody's got to figure out where to put it in the data center. Is there space, power, network, cooling, everything else that's got to be capable of doing that? And then, okay, now do we have the software, the licensing for the software and everything to actually install it? Mm-hmm. And then is the networking there for this segment of the business to get to it? Is it big enough to handle what we're wanting, and everything else? And database as a service abstracts a lot of that. I mean, obviously cloud provides and is pushing a lot of that direction for, I can just click and I have a VM.
Yep.
Now, when you remove that need for the weight of building out a data center, now that's going to be moved one level further. How can I move it so that I'm not waiting for a database team to build me a database? I want it, and I want it now.
Fantastic. And building on that lines, like how do you take the necessity away or reduce the time it takes for provisioning hardware, for like the networking, the setup, like all of that stuff? How do you decrease that portion? Is it by moving to virtualized infrastructure and having a larger base of hardware? How do you envision?
I think that's the biggest answer, is moving to some kind of virtualization, whether it's an on-prem, your VMware, or whether you're in a cloud, a public cloud. You move to some kind of aspect of that cloud idea and virtualizing as much as you can.
Got it. So basically commodity hardware, right? Like
right.
Commodity hardware and armed at the end of an API in some sense.
Exactly.
Right? So anyone can do this. Got it. So let's talk about that shift, right? Like let's talk about the shift to commodity, right? Like commodity often means failures, right? Like that is a part of the game, and you still want your resilience and reliability, right? Like, so that
Yes.
brings up two questions. Like, the first question is, how do you make this operationally efficient? Like, how do you make sure you don't hire even more people, because now you have machines that you can get provisioned really quickly, but they can fail more often, so you have to do more work because there's more demand, there's more failures. So,
Well, I think it's with anything else. Yes, there's more demand, there's more failures, but again, you're still getting into that automation. How can I automate the recovery of a failure? How can I I remember way back in the day working as a consultant at a site, and no matter what happened to your laptop, they just came in, their admin or whoever came in with a floppy disk and a CD-ROM.
okay.
No matter what the problem was on your hardware, he threw in the floppy disk, he put in the CD-ROM, and he rebooted your machine. He walked out a half an hour later, and
It's all working. Yeah.
it was completely remastered. So whatever you'd done to screw up your workstation was fixed.
Yeah.
And I think it's that kind of automation is starting to move over into our server realm. No matter what it is, we just rebuild it, and we're going to rebuild it as fast as we can. So instead of patching a system, just rebuild it.
Makes sense. So, okay, so with all of that context, where do you see, the value of distributed SQL in all of this?
That gets into just how fast can we deploy a database on commodity hardware. The Oracle databases I had worked on, you get some of those running on an AIX system or some of these big iron boxes where you've got 64 CPU you can throw at it, or it's 128 and massive, massive machines.
Yep.
That's not commodity.
Yep.
Commodity hardware is going to be a couple PCs, or here's 4 CPU or something, simple.
Yeah.
But then how do you scale that so it's still doing the same workload as that massive iron? And that's where distributed is going to come in. Now just split it up even more, that it's not just sitting in a data center. And I think that's where it comes in. Now we can distribute the load across multiple workstations, but we can get into handling the fault tolerance. And because that's every DBA's nightmare, is how do I recover from a fault? How do I handle a DR situation? And distributed computing and distributed databases, I think, really start to solve that answer, is how can I have my database up as often as possible, but I can still patch it, I can still upgrade it, I can still do all these changes without having an outage window needed.
Makes sense. And yeah, and how do you, and practically, do you see the scale as in the number of these systems increasing? Like, because I keep hearing about that from a lot of places, like the number of such microservices or applications also increase, thereby the number of such databases that you have to handle, the farm also increases. Is that true?
Yes, I think it is. I think it is that it increases the farm, everything, every aspect of it. And some of it's just the aspect of everybody moving to mobile devices. We want something, who's using that mobile device? Who's using your website? What time of day? Back in the day, everybody did their 9-to-5 job. And so what if a system went down at 7 p.m., nobody was in there to use it? Nowadays, if you're on your phone, your system's expected to be up no matter what time of day it is, because somebody could be using it.
Yep.
And so how can we handle that my load is 24/7 now?
Got it. And that's where it's the API and automation meets the zero downtime, and so you're able to do this at a larger farm. Got it, right. That's just this is just from the DBA aspect, right? There's of course the scale and all of that happening inside the app, but it's just how do you automate away the manual portions of an ever-increasing farm of use cases.
Exactly. And then as a DBA, I'm going to be in there. I may have more than one database I have to look at and watch over, or set of hardware. I'm going to have large institutions. I could have 100. I could have 200 of these things I need to look at. I don't have the time to look at and nitpick and walk through the logs of every system. I've got to be able to look at from a central point or some area, look at a few points and have it tell me this one's looking unhealthy, or to be able to go through and just see, oh, okay, I've got 120 that are good. I've got these 3 or 10 or whatever it is that they might have some questions and whatever else.
Got it. So in the journey to virtualized infrastructure, right? I have two questions for you. One of them is just VMs, and we've been in many conversations where there is this notion of how do are VMs optimal in their performance, especially because they are multi-tenant, right? Like there's multiple things running. So Is that a DBA nightmare situation for you, or is that under control because it gives enough observability? How would you view that?
At times, it's not my monkey, not my circus. Somebody else is managing it, so I'm just going to let them worry about it. And other times, I'm like, as long as it's working, I'm going to go with it. I know there's a big push for Kubernetes and containers and a lot of those.
Yes, yeah.
That's just one more layer. To me, that's one more layer of virtualization and how I can run a smaller job on something. And I'm sure those could come into play, and those are great. Right now, for me, it's just somebody else is held in it. Where is my database running, and how can I see how the database is performing on that?
Got it. So when you think about, okay, so then that brings us to, in a distributed substrate with distributed systems, when you have a database that's distributed SQL running, how has your notion of observability changed? Like, how do you think about it in the traditional database world versus a distributed SQL or a distributed database on cloud native infrastructure world? Has anything changed?
I think it really changes in how you go look at what the problem is that your database is having. The old Oracle realm, non-rack, you have one place. You have one log that you go look at. You can look at one set of, you can log into that database and run, here's my 5 main queries that I'm going to run to see how performance is running.
Yep.
Now, a distributed system, how big is your distribution? Is it 3 nodes? Is it 12 nodes? Is it 64 nodes? Are you logging into all 64 of those things, trying to run those same 5? Now you're running 5 across 64, and okay, what's that? 400 different queries that you're running?
Yep.
That's too time consuming.
Yeah, it's untenable. Yeah.
You're just not going to be able to do it. So you're looking for. I still have to have one central point to go look for what's happening in that database, and some control point that tells me how all the nodes are acting in general, so I can see, hey, I've got a 12 node cluster, 10 are good, I've got 2 unhealthy, what's happening to the 2? At that time, I may need to go look in and drill into a specific log to see actual errors, but I need some place where I can look at a higher level what's happening across that cluster.
Got it. And in distributed SQL, right, specifically say with YugabyteDB, that's very Postgres compatible, right? Like, how does that interplay? Like, I know you're from Oracle, you have a lot of experience on that side, and Postgres is similar-ish to Oracle, right? It's not too terribly different. So how does that simplify or complicate a distributed SQL database for you? Is that more familiar, makes it easier, or is this like similar enough but it's different, so you got to think differently? How would you characterize that?
I think it's helpful. It makes it similar enough that it's not a huge paradigm shift to move from one to the other. I can still think of it as a Postgres database overall and go, okay, here's what I can do. These are the things I know that hurt a Postgres database. These are the things I know that work really well. And so you can carry that knowledge forward. And from an app dev team that's like, okay, yeah, I've worked with Postgres before, but I've never worked with Yugabyte. Well, you've worked with Postgres. Just carry that knowledge forward, and you can get that. So I think there's a lot of hit the ground running is what you're capable of doing.
Yeah.
And that's really a lot of help for a lot of teams, because this idea of, well, management always comes in and tells you what your deadline is before you know what it's really going to be.
Yep.
And as much as we can hit that mark and go and do those things that we need to as fast as possible with as little effort as possible is, I think, what every DBA team and every app dev team does. So just having that seamless, it's Postgres or it's an Oracle and Postgres being similar enough. I've seen Oracle developers go, oh yeah, I've got this, I can go.
Yeah.
And so there's a lot of there's not a lot of learning time and trying to get up to speed.
Fantastic. And you're both DBA and in the DBaaS side, like in that side of things, right? If you're building a traditional database, and you're using that to build a DBA as a service, how do you deal with things like, it's got to be complicated to deal with things like, upgrades or security patching or some of these day 2 operations. Like, do you still do the downtime notice? Is that how you do it, or is there some way you try to hide it? Because a distributed SQL database, I can understand, is built for that, but how do you handle it in the traditional world? The
traditional world, you've got to have a window, you've got to communicate, you've got to have something pre-scheduled, and depending on how big your app is, and communication for it. It may be you're notifying your customer, downline customer, of whatever that is.
You got to chase that
months in advance of saying, hey, we're going to do the upgrade here. And then you run into the problem that if something goes bad and, we couldn't even start. We've got to move that date. And so you're constantly having to work. Where's my outage window? When can I take this system down? And can we support that? And I've seen with distributed systems, can I patch a cluster? Can I take one down, bring it back up, see how the cluster is healthy? Next node, do it.
Yeah.
Next, and just work it across. And you can work through scenarios where working with the application team where they're like, okay, yes, we saw an error, it's a noticeable error, but our application picked up and reconnected to a different node in the cluster, and we're still moving. We're handling transactions, we're handling work, we're good to go. And so you still have to have a change window and notify people that we're going to do work, but it's the fact that the app can still be up and handling things, but there may be errors as compared to everything's completely down. And the user seeing like a 500 error, a 404 or something like that.
Makes sense. And with the increasing number of applications and the mounting pressure to quickly finish the maintenance job, that's got to be tough, right? Because one means you got to do more maintenance, and the other means you got to do it quickly, and those two often aren't friendly to each other.
Right, and in the old Windows, like an Oracle database, quick PSU, quick patch. Some databases you could get that down up half an hour, 15 minutes. You could get it through. Major upgrades, it may be longer. You do a DR scenario, you're doing some kind of RMAN replication behind the scenes. Okay, you got the main done, now you've got the patchworks, now you got to redeploy it on this. And it could be a 3-hour process where you're out, and at some point in time something goes bad. It's a DR scenario, and we've got to either roll or is that down and we can't roll, what's wrong? And you can really put yourself at an impacted situation. Distributed, again, your app's up the entire time. Your database is up. So you're communicating, hey, this could happen, but you're working through it and it just goes.
Fantastic. So fair to characterize your, seeing the distributed SQL future as bright, like, because...
oh, yes.
Okay.
From a DBA perspective, I could potentially, depending on the app, I could potentially do something during business hours instead of having to do it at 2 o'clock in the morning. 2
a.m. Yes, exactly. Makes total sense. Makes total sense. And let's talk about the future. We have a few minutes left. So let's talk about the future of distributed SQL, of cloud native, of modernization. Like, where do you see things going? Any specific requests of distributed SQL and where it should go? Like, any thoughts?
I think the next one was just going back to that scenario of doing the patching or whatever, where the application is, it sees the outage and it has to reconnect. Maybe a little bit more dynamic in the sense of distributed transaction, where node A goes down, but node B can pick up the work, and so the application doesn't necessarily see the outage of the single node. I know there are some platforms that claim they can do that, and it's going through and proving that it's possible and doing that full stacks and being able to handle that kind of distribution. So
you're talking about midway in a transaction that node is taken down, and because there's enough metadata, you can continue that from a different node.
Right.
Yeah, that makes sense. I think this is...
But maybe not having all the front end work that, like, some may do that by having everything look as a single database from the front. You come into a single choke point. And then it handles and it distributes the workload out. And this is more of each node's doing its own work, and maybe the nodes talk enough that I was here, but I know that these 2 other nodes are in the cluster, whatever it is, and I'm talking to them also through the whole thing. Yeah,
that makes sense. I think funnily this is not you're not the first person to make this request, which is pretty interesting. But I think this is something we really have to look into, which is why can we not continue transactions? The thing that we have started doing, though, is to drain leadership from the node, so to make it a little more graceful. But but that's only in the case of planned maintenance, not unplanned outages, right? So that's that. What about things like thoughts about things like auto scale and that type of stuff, or things like multi-tenancy and consolidation of workloads? Anything on those sides that you find exciting as a DBA?
Just all of it. From a simple perspective, all of it. I mean, the scaling, businesses are always looking at ways to cut costs.
Yep.
And when you can scale either through scheduling, I know that during these hours of the day, this time of the week, whatever it is, I really don't need massive compute.
Yeah.
Going back to my original, I managed a warehouse system. That warehouse may not be. We weren't Amazon.
Through the weekend sometimes.
We weren't Amazon. We're not shipping 24/7.
Yeah.
But so we only needed the compute from say 5 in the morning through about 6 at night, 7 o'clock at night. After those hours, run some billing, run some reports, and by 9, 10 o'clock at night, that's done.
Yeah.
We don't need a massive compute from 11 o'clock at night through 3 o'clock in the morning.
Yeah.
Scale back. If Distribute could do that, and then at about 3 or 4 o'clock in the morning, scale back up, start ramping up to handle that, and provide that cost savings to the business. I think that's increasing. Plus, you just get into certain facts. I mean, I know that at some large sporting events, our cell phone providers roll out trucks to handle the load. They know ahead of time something's going to happen. But there's always the aspect of who knows when that's going to happen. How do I scale up to handle this crazy load that already happens?
Yeah.
And I think that's the other intriguing part of auto scaling. I see performance-wise my database is going. I need to scale to match to capable of handling that.
Makes sense. Makes complete sense. And thoughts on security?
It's got to be there. We're financials at every level, at rest, in transit, just every aspect of it. And then, of course, with that, the ability to provide my own key into it and not trust somebody else providing my key.
Bring your own key.
Something happens, I need to be able to vacate that premise or whatever it is, pull my key with me, and it's encrypted. And there's a lot of just being able to provide those things. And that goes along with not just the encryption at all levels. I think it gets into authentication, multi-factor for the data DBAs. How easily can I do that? Authentication to the database, authentication to a control plane that may be watching all of it, and those kind of things.
Got it. Makes total sense. Other thoughts about distributed SQL? Any closing comments, closing thoughts?
Definitely has got to be the future, because I see what's out there and how it's doing, and that's what everybody's moving that direction on the app side. They're asking for the database to catch up, and that's where everything's going.
Awesome, fantastic. Hey, thanks a lot. I really appreciate your time.
Sure.
This was a really fun conversation. Very, very insightful from the Oracle perspective also. So yeah, thank you.
Thanks. It's been good talking.